We know that differentiation can be used to find stationary points on curves. These are points where dy dx is equal to 0. There are three types of stationary points. This is known as a maximum, or more properly, as a local maximum, because the curve may come around and go up above the maximum point, but it's the maximum in this region, hence local maximum. Then we have the local minimum. We also have what's known as a horizontal point of inflection. So the gradient is 0 here, but we can see the gradient's positive beforehand and after. And of course that could slope the other way. These types of points can be identified in kinematics using calculus. So let's suppose we have an object here, which moves off to the right like so. It stops instantaneously at this point and then comes back. So the maximum displacement is where the velocity was 0. V is ds dt, so we're finding where ds dt is 0 when we find where velocity is 0, and that was the position of maximum displacement. If we're asked for a minimum displacement, it's just at the other end. Now, if this object continues moving in the subsequent motion, there may be a minimum, or it may just be at a start or end point. Our object started at the origin, and therefore the minimum displacement would be 0 for the motion that we saw. So here we have another object, and it's going to move off to the right and then move a bit further on. That would correspond to a horizontal point of inflection. It moved, it stopped, but then it continued to go. So we wouldn't have found the maximum in that case by finding where ds dt is equal to 0, because it continued on in the same direction afterwards. So to reiterate that, this would be an inflection point. The velocity is positive, then 0, then positive again. Let's concentrate just on maxima and minima. Max or min displacement will occur when velocity is 0, or perhaps at the end point of a motion. ds dt is 0 in that situation. Max or minimum velocity will occur when the acceleration is 0, and therefore dv dt is equal to 0.